Thank you everyone for joining us. Today we're going to be discussing the 2024 International Energy Conservation Code as a sneak peek of what's coming. Uh, Today your presenters are myself, Robert Schlorf, and my colleague Ryan Siegel, both from CDAC. Our learning objectives today are to identify key changes between the 2021 IECC and the 2024 IECC, identify how compliance with the Illinois Energy Conservation Code will lead to safer, more resilient buildings, explain how compliance with the updated Illinois Energy Conservation Code reduces pollution, and describe the Illinois amendments to the 2024 IECC and their impact on compliance. All right, who are we? We are the Smart Energy Design Assistance Center. We're an applied research group at the University of Illinois, and our mission is to empower organizations with practical solutions for climate, energy, and sustainability. What do? We assist buildings and communities in achieving energy efficiency, saving money, and becoming more sustainable. CDAC is the Illinois Energy Conservation Code training provider, and this training is sponsored by the Illinois State Energy Office, and we thank them for their support. CDAC is a preferred education provider with the ICC and AIA. If you provided your member information upon registration for this event, we will handle your certificates of completion for you. If you don't get your certificate within a certain period of time, reach out and we'll be happy to work that out for you. Our Energy Code training program does include a technical support hotline. You can reach us over email, energycode@illinois.edu, or we do have an 800 number listed there on the screen. We often recommend emails just as a good way to get a written response back that can then be shared amongst a project team or design team to have everybody reading off the same sheet of music. So we do generally recommend emails, but the phone line is always there in case you have a quick question or just want to chat on the phone. We also have online resources available at our website, including previously recorded webinars and workshops, as well as on-demand training modules that offer CEUs. Those are done on demand at your own pace, so you can jump in and out of them. We have a recent one. Our latest one is on the Illinois Stretch Code. Our Energy Code training series. So we're wrapping up our program year. Today is our last presentation for this program year, and we will be working on the topics for the next program year. Illinois Energy Conservation Code. So just to reiterate this, the current Illinois Energy Conservation Code is the 2021 IECC with Illinois amendments, or sometimes the 2021 ILECC. This is the code that applies to any projects with permit application dates dating January 1st of 2024 or after. If the permit application date is before January 1st of 2024, then it would need to comply with the previous 2018 IECC with Illinois amendments. So just remember that the trigger there for which code it complies is the permit application date. Access to the 2021 Illinois Energy Conservation Code. You can access it online via the ICC Safe website. We often find this is the easiest way to navigate ourselves in our office. There's a really nice table of contents along the left-hand side. You can also easily use the search function, Control F, to search for certain keywords and topics throughout the document. Pretty easy to find your way around and is a pretty helpful resource. Similarly, we're not going to be touching on the Chicago Energy Transformation Code today, but you can access that code through the same website. The 2024 IECC, you can also access the 2024 on the ICC Safe website. So the 2024 was published in May. It has been adopted as of May 13th of this year. Sorry, it was published in May of last year. It has been adopted as of May 13th this year, 2025, and we are expecting the enforcement date to be November 30th or essentially December 1st to make sure that it lands on a weekday. So we are expecting enforcement of the 2024 IECC with Illinois amendments December 1st of 2025. And Ryan will talk a little bit more about that as we get further in here. Just a reminder to please insert any questions into the Q&A panel at the bottom of your screen. We would also like to ask that if you are watching with others in a conference room or with a group of people, go ahead and insert a question that includes all the names of those watching. We'll dismiss it on our end, but that keeps a nice record for us so that we know who is watching at the beginning, so that we can get certificates out to those who need them. So if you are watching with a group, go ahead and submit a question with those who are in attendance with you. Okay, I've got a couple quick updates on really broad updates on the 2024, and then I'm going to pass it off to Ryan. So, the first update is that the 2024 International Energy Conservation Code is now being developed through a standards development process and not through a codes development process. For those that use the code, this isn't going to change a whole lot. Functionally, it's still going to be the same, but the development of the code is now going through a different process. This is a consensus-based process that includes voices from code officials, trade groups, manufacturers, etc. So bringing more people to the table to talk about the provisions and requirements within the code. One of the big things for the 2024 this code cycle is that there have been several appendices added. There are about 10 appendices within the 2024 code. These are not a part of the code and not required unless they are specifically adopted, but they've been included as vetted language on certain topics that wasn't deemed to be right for the primary code, but they pushed them into the appendices so that any jurisdictions that could or that would like to enforce those requirements or would like to have further vetted language around those requirements and topics can go to those appendices and use that language. So there are a lot of appendices. They may not be required unless specifically adopted. Couple quick highlights. So we do see a continued improvement in efficiency for the overall requirements of the 2024 code. It's roughly a 7 to 9% bump above the 2021 code. I believe the determinations for the actual the finite amount there are still being developed, but this is what is anticipated in terms of the efficiency boost over the last over the last edition of the code. There are many revised definitions. There are lots of new options and pathways for increased flexibility throughout the code. And then, as I just mentioned, there are several appendices that touch on topics such as energy storage, demand response controls, electrified buildings, zero energy buildings, topics like that that weren't included within the main code, but there are appendices that touch on them for those that are interested in digging further or that are interested in requiring anything further. With this, I'm going to launch our first poll question here. So our first poll question is, when is Illinois planning to transition to the 2024 IECC with amendments? Your options are July 1st of 2025, November 30th of 2025, January 1st of 2026, or I'm not sure. The second question is, how does the updated Illinois Energy Conservation Code reduce pollution associated with buildings? There is no reduction in pollution. Improved building efficiency over the previous code results in less fossil fuel energy use on site or at power plants, or by sequestering pollution into the building materials. Give a few more minutes here. Looks like we're almost done with this poll. All right, looks like I've got numbers matching on both, so I'm going to go ahead and end here, share the results. So it looks like the vast majority of everybody listening is already listening well. The transition to the 2024 IECC is planned for November 30th of 2025. And then for question two there, how does the updated Illinois Energy Conservation Code reduce pollution associated with buildings? The correct answer there is the second answer. Improved building efficiency over the previous code results in less fossil fuel slash energy use on site or at power plants. With that, I will hand it off to Ryan to start taking us through some overviews.
All right. Thank you, Robert. So we're going to start with the commercial side of the code. And so we're looking forward. You'll start to see some Greek language creeping into the code, looking at thermal bridges, recognizing that as we've been getting better and better envelopes, these thermal bridges are becoming more and more important for managing energy consumption. We also have several new energy efficiency measures. We'll touch on that a little bit later as far as how much that's been expanded, as well as awarding additional points or perhaps more granularity by awarding more points for a portion of energy savings, as well as raising how many points that you need. So Air leakage, that was new to the 2021. And so in 2024, starting to adjust those thresholds down as people are understanding how to build better buildings that can be achieved without necessarily adding a lot of extra cost to get tighter buildings. There is also the new Total System Performance Ratio, or TSPR, that is available for several building types uh, that may be perhaps a little bit more simplified to achieve compliance using that versus the traditional systems are uh, 403. And so using that TSPR to achieve that and demonstrate that efficiency. Also added new occupied standby for several space types. So whereas the building can almost go into a coast mode when you are near the occupied conditions, but the room is not presently occupied. We, of course, continue to add more spaces to the occupant sensor list for lighting controls. Also adding dimming requirements to several spaces. So previously we focused on occupant sensing, now adding dimming requirements for many spaces. And that daylight threshold previously was 150 and 300 watts. That is being reduced as, again, controls become more common and perhaps more available and less expensive to install. That cost-effective threshold continues to improve. And also adding or introducing demand responsive lighting to the code. It's not being added as a requirement, but at least introducing a concept into the code. As well as energy monitoring. This is something that was also added fairly recently to the code. This has been greatly expanded for the for requirements to do energy monitoring. I mentioned earlier about that additional efficiency list being substantially longer and more granularity. So a point is worth a little bit less now, but rather than incrementing, you know, 0.5%, now we can increment in tenths of a percent. So that gives you a little bit more precision when doing this. And also adding renewable energy requirements to the code. So buildings being required to install some renewable energy for that. Chapter 5 has been greatly revised. You will see a lot of blue text if you go through and look at Chapter 5. Blue text in the online version is denoting new or substantially changed text. So if you go through Chapter 5, you will see a lot of blue text in there. Especially for change of use. Change of use used to be a fairly small section, has a very big impact when you trigger that, but it was fairly small. So this is one area to focus in on because a lot more projects are going to qualify as change of use where in the past they may not have. So also adds some additional efficiency requirements for larger for additions and large renovations for that. So whereas previously it's just been very much about whatever you touch, that's what you need to bring up to standard. But as the code is becoming more flexible and saying, okay, rather than dictating this is how you will meet the code, providing that additional flexibility through the additional efficiency measures, which is how do you wish to turn this building up to 11 and give me that little push extra. So for existing buildings, there's now a section to bring additional efficiency into alterations and additions. So, so those are kind of the highlights of the commercial side. Looking at the residential side, also see that the intent is greatly expanded and also calls out that the code is focusing on cost effectiveness and life cycle cost, recognizing that every time we bring a new code and the code will improve, often there comes with it some added cost. but recognizing this is balanced with an added benefit over time too. So covering that in the intent and calling that out specifically. The envelope backstop previously was just a flat backstop, actually referred to, I believe it was referred to an older code. Now the envelope backstop is referring to the current code and is just an adjustment factor. So rather than having to have two code books to do that, you're able to do it with just one. This is more of a terminology, but just want people to be aware. Previously, we used the term UA in the code. This has now been transitioned to TC for thermal conductance. It's a little bit better descriptor as far as what it is. So if you do see TC, we want you to be aware of that change and that it didn't throw you off too much. Also, several new definitions in this code cycle. The inspections have also been revised and divided slightly differently for recognizing that part of that is the construction timeline and the construction order is such that the inspections weren't quite in a real logical perspective. So separating out the air barrier inspection from the insulation inspection because it can be very difficult to inspect an air barrier if it's already been covered with insulation. So that you may see some differences as far as the inspection order in which your jurisdiction may request for. Also, trimming that air leakage backstop, similar to the commercial side, that air leakage continues to decrease. Also new to the residential provisions is the multifamily sampling protocol. This previously was in the commercial provisions, but not in the residential. So they've brought that over to the residential. Also having some new allowances for outdoor systems. Again, previously in the residential, there was almost no provisions for outdoor heating systems. Part of that was because heating systems were required to be sized using a manual J. Well, if you try to put that outside, there's no way to perform a manual J to determine the appropriate size of those outdoor heating systems. So trying to align the commercial and residential provisions and borrow back and forth. So these are provisions that previously had been in the commercial provisions that are being brought into the residential side. Also added some additional requirements for homes and dwelling units that are over 5,000 square feet, recognizing that these very large homes and dwellings represent a very large impact on the energy footprint. And so the code is adding some additional requirements for these larger homes to say, if you're going to build something that large, we want you to go above and beyond just the standard efficiency of those. And also, speaking of additional efficiency, previously in the 2021 code, it was just a choose one package. You had a handful of options and it was just choose one. Additional efficiency is now a uh, points-based approach, recognizing that some of those options in the past had a greater impact than others. And so this is kind of acknowledging that and saying you just have to collect a certain number of points, which varies depending on what climate zone you are in and the various measures for that. As far as Chapter 5, again, for existing buildings, so if you are doing what's called a substantial addition or alteration, or really specifically a substantial alteration. This is a new definition for 2024. There is then the requirement to do some additional efficiency for that. Also for 2024, duct testing may now be required in existing buildings for that. So if you're doing substantial work to an HVAC system, duct testing may now be required. So kind of the highlights for 2024. We do have just a handful of amendments for the 2024. That is something Illinois has tried to take a fairly light touch as far as amendments for the 2024 cycle. So if you familiarize yourself with the 2024 International Energy Conservation Code, you'll be fairly well up to speed. For those of you who do really wish to get into the nitty-gritty, you may find the specific text of the Illinois amendments in the May board packet for the Capital Development Board. It can be a little difficult to read because part of that text is removing the amendments from 2021 and then adding the 2024 amendments. So it can be a little difficult to read. But there's three primary amendments for Illinois, two in commercial and one in residential. So the first one in commercial is for buildings that don't use heat pumps for heating and domestic water, requiring that they get a couple of more credits in the additional efficiency measures. So an extra 25% more credits. So this represents on a building scale an increase of about 1 to 2% efficiency gain for the entire building. Part of this is recognizing that combustion heating equipment uh, or even electric resistance is substantially less efficient than modern heat pumps that can easily reach into the 300, 400, 500% efficient range. So that's part of what this is introducing, is saying, if you don't use heat pumps, we want this building to do just a little bit extra. And again, this is overall on a building scale, 1 to 2% improvement. So not a dramatic change. The other is electric readiness. So this is something coming over from the Illinois stretch code from the last cycle, adding some electric readiness requirements. You can see here it is restricted to only certain building groups, as well as equipment. So looking at space heating, connected to a condenser or air conditioner, if you will, 5 ton and less for space heating. So this is not your large, 10, 15, 20-ton units. This only applies for uh, 5 tons and smaller. Similarly, for service water heating, these are smaller units with 50 kBTU. So this is, again, your residential size and scale for this. Also applying to residential cooking equipment and residential clothes drying. So you see these are more designed to capture residential type uses that may be in commercial buildings for that. So, and what this kind of calls out is where you do have combustion equipment that you are bringing a raceway or cable to enable that uh, option of you continue to use gas or electric going forward. So making that uh, ability to have that decision periodically at a much lower cost than trying to install that cable or raceway later. So this is the one change for the residential side. And what this is this was some new language that was added as part of the additional efficiency sections, which allows you to reduce the stringency of your building envelope if you made some trade-offs. And so Illinois is eliminating this. Part of this is recognizing that buildings, for the most part, get one chance at their envelope. They're going to have many chances to improve lighting and HVAC and domestic hot water, but they really only get one chance to get their envelope right. And so trying to discourage trading that envelope away if we can. So those are kind of the high level things. So I'm going to go ahead and launch our second poll here. So the first question is electric readiness requirements added to the 2024 IECC by Illinois amendment apply to commercial cooking and laundry equipment. True or false? The second, which Illinois amendment helps to ensure compliant buildings have passive resilience? Electric readiness for small equipment in commercial buildings, a nominal increase in building efficiency for commercial buildings without heat pumps, eliminating the trade-off permitting a worse performing envelope, or no amendments address resiliency. All See, we do have a question that has come in regarding the city of Chicago. I would anticipate that the city of Chicago is also working on an update to their codes as well uh, to address the shift up to the 2024 IECC. But we don't have specific information on that yet. And looks like just about everyone has, many people have gotten in, so I'll go ahead and end this poll. All right, go ahead and share the results. Okay, a little bit of a trick question here, apparently. Electric readiness requirements do not apply to commercial cooking and laundry equipment. It's only for residential equipment. So the recognizing that just because you're in you may have residential occupancies in commercial buildings, so it's only for residential cooking and laundry equipment. So interesting to pick up on that. Second, okay, definitely some hard questions in this poll. So the correct answer would be eliminating that trade-off, permitting a worse performing envelope. So that's the passive resilience, because again, that envelope is the critical thing for passive resilience. Recognizing that's the part that counts when the utilities are out. So with that, I'm going to turn it over to Robert to start in on our commercial updates in more detail.
All right, thank you, Ryan. Going to keep us moving along here. As I said, we do have a fair amount to cover today, so we may be moving a little bit quickly, but we're going to try to get through all of our slides here. So Chapter 2, new definitions. So we do see those Greek characters coming in, the chi and psi factors, those are related to thermal bridging, which I'll cover just a little bit more here in a bit. We have a new definition for common areas. Demand responsive controls is defined, energy storage systems, greenhouses. We have to define the new total system performance, HVAC compliance method, occupied standby mode, roof replacement, which is different from a roof alteration, which I'll touch on a little bit later on, and then that substantial improvement definition that becomes a triggering point for existing building projects and whether or not additional efficiency measures are required. So a chunk of the new definitions, this is not all of them, but this is a chunk of them. Moving on, there have been some updates to the required documentation for commercial projects. So we see here that they've added in documentation of air barrier and air sealing details as well as thermal bridging. So we need to document those elements within the project documentations, the construction documents in some way. We also need to make sure that we're documenting the locations of raceways and pathways for renewable systems as well as specifically marking out areas for energy storage systems if they exist, as well as the rated capacity of those systems that are either planned or installed. So it's a little bit of additional documentation for commercial projects. All right, so going to talk a little bit about the additional efficiency measures here. And so this is for the commercial side. Uh, Increased options and points, as we've discussed. So each credit is now worth 0.1% of an improvement above the baseline. C406 aims for roughly a 7% improvement for each project. So as Ryan mentions, this is how we turn each project up to 11. So that moving up to 11 is about a 7% improvement for each project. Energy credits must be over and above base compliance. So an example of this is that we can't install better than code minimum windows and take advantage of that in the total conductance or what used to be UA calculations and C406. We can only take credit for the better than code minimum windows in one location or the other. So we can't double dip on our measures here. There are some trade-offs allowed. So another addition to the additional efficiency measures section is a section requiring renewable and load management credits. So that's what the R/LM credits stands for. So there is a little bit of ability to trade off between additional additional efficiency and renewable and load management credits, but those that trade-off is guided within the code. So if you're transferring one way, you have to look at table C406112. If you're transferring the other way, there's an equation that you can use. You can area weight the additional efficiency credit requirements as well as the renewable and load management requirements. They're provided within the code by table based on building type. So or building occupancy type. So you can, if your building has multiple occupancies within it, you can area weight the requirements based on the area weighting of your different occupancies within your building. So we talked about the expansion of options within the additional efficiency measures. So if we look at 2021 IECC, there were roughly like 15 options. We had one that was associated with a heat pump water heater. Now in the 2024 code, we've got something like 32 options. And as you can see, we have, I think, 10 options that are related to service water heating rather than the single measure beforehand. So this is what we're talking about when we mean that the code has been expanded for additional options and more flexibility for project teams to comply how they best see fit for their project needs. Breaking down the requirements a little bit further here. So this is the additional efficiency and renewable and load management requirements. So if your project is greater than 2,000 square feet, that project has to comply with additional energy efficiency requirements. If it's greater than 5,000 square feet, we're going to comply with the additional energy efficiency requirements as well as the renewable and load management requirements. And then if it's a build out greater than 1,000 square feet, these are projects without final lighting and HVAC. There are some specific requirements within C40211 that apply. There are some exceptions for core and shell buildings where not less than 20% of the floor area is without final lighting and HVAC, but there are some specific criteria there that must be met. But for most projects, remembering these main three categories might be a good start at understanding these new requirements. Taking a quick look here at some of these tables. So in 2021, we needed 10 points or 10 credits. In 2024, we're going to need somewhere between 35 to 90, depending on the building type and location. If we take a look here at these tables real quick, the point values or credit values in the 2021 table are much lower than what they are in the 2024. So even for the same measure, the amount of credits offered is going to be higher under the 2024 IECC. So we're requiring a larger number of total credits, but each measure is also generally offering more credits than it may have under the 2021 code. So this is they're just kind of pushing everything up to allow for more options, and as we said, far more options, up to 32 different options for the measures here. All right, so thermal bridging, we'll talk just a little bit further about this, but not too much more today. So the two factors that have been defined for thermal bridging, one is in reference to a point source. So think of like a fastener through an assembly. If it's a metal or a conductive fastener through an assembly, that fastener itself is becoming a bridge for heat to flow inwards or outwards through that assembly. We also have linear thermal bridges. So the thermal image there that we showed earlier, if you look carefully at that thermal image, the overhang that you see above, we see some really bright yellow-orange lines that are going horizontally across the screen at the bottom of that overhang. Those yellow lines are showing us that the concrete structure supporting this overhang, there is no thermal break within the structure. We can clearly see that highly conductive concrete is transmitting the heat either in or out of this building assembly. So that would be more of a linear thermal bridge where it's not just a single fastener or point, but it's along a linear dimension. So these defined terms within the code will tie into the requirements for thermal bridging documentation. And depending on what design you have, what elements in your design, you may have to use both or either of these factors to accurately document the thermal bridges in your project. So envelope air leakage, as Ryan mentioned, the requirements for envelope air leakage have been ratcheted up a little bit. So the air leakage limit has been reduced from 0.4 in the 2021 code down to 0.35. And this is at 75 pascals of pressure, test pressure that we do for commercial buildings. There is still the kind of the buffer for performance or the pass with diagnostic testing and remediation. So if the project achieves between 0.35 and 0.45, that project can pass without further leakage testing as long as diagnostic testing and remediation is performed. So in the 2021, this was also available in the 2021, and the limits were 0.4 and 0.6. So functions the same, but we can see that those limits are reduced. So efficiency is increased within the 2024 code. Okay. Going to touch a little bit on the new HVAC compliance method. So this is an alternative to compliance through C403. It's available to only the certain occupancy types listed there on the screen. And what this allows you to do is trade off performance within the mechanical system. So some components of the mechanical system could be higher than code minimum efficiency. Some could be lower as long as the overall HVAC system complies with the requirements. So this is going to rely on an equation to determine overall mechanical system efficiency. But a key here is that this only applies to certain occupancies. And if you can't apply this to your project, then you must follow traditional prescriptive compliance through C403, or your project must go through the performance path of C407. So this is a prescriptive alternative. It still is within prescriptive compliance, but it's an alternative to C403. Okay, occupied standby. So Ryan touched on this a little bit earlier on, but basically, excuse me, basically the idea here is that if we have a space that's scheduled to be occupied, but an occupancy sensor indicates that no one's there, we want to be able to adjust the settings, set points within that space because there is no one in there, so we don't necessarily need to have the full airflow and make sure that we're right on our temperature set points. So the spaces listed here need to have occupied standby controls. It's a fairly short list at the moment, but includes things like enclosed offices, conference and meeting rooms, lounges and break rooms. And these controls need to have the functions that are provided here on the in this section. So we need to be able to adjust the heating and cooling set points by at least 1 degree. It can be more than 1 degree, but by at least 1 degree. And then we need to be able to adjust the airflow supplied to the zone. So that basically, if the zone doesn't have anyone in it and it's at set point temperature, we don't need to be providing ventilation air into that space. So that's what these occupied standby controls are for. And then there's also specific requirements for multi-zone systems. Occupant sensors. So getting into some lighting controls, as Ryan mentioned, there are some new spaces added to the occupant sensor list. So we now have computer rooms and data centers, as well as medical supplies and healthcare facilities, laundry and washing areas, and then telemedicine rooms and healthcare facilities. So again, notice that they're being very specific about the healthcare facilities. We're focusing on spaces where patient care isn't provided. Moving on, dimming, we have an entirely new list of spaces that require dimming controls. There is some overlap between the occupant sensor list and this dimming control list, so keep that in mind. But many spaces will also require dimmers under the 2024 code. Daylight harvesting. Power thresholds have been reduced both in the primary and the secondary zones. And then there's an exception for enclosed offices that are less than 250 square feet. 250 square foot office would be limited to like 155 watts of total lighting anyway. But the main goal here is to prevent spaces like in the picture from being lit when there is adequate daylight available. Okay, energy monitoring. So energy monitoring now applies to new commercial buildings that are 10,000 square feet or larger. In the 2021 code, this was 25,000 square feet. On the electrical side, we now need to monitor hot water heating as well as the other items that were previously listed under the 2021 code. And then for non-electrical monitoring, this is an entirely new section for 2024. We want to monitor total HVAC systems, process loads, service water heating, or other miscellaneous loads that may not be electrical loads. This sort of data gathering is really, really helpful in terms of knowing how your building is performing or even knowing what needs to be fixed if it's broken. Touching quickly on the renewable energy requirements. So this applies to all commercial buildings in climate zones 0 through 7. On-site renewables, there's a requirement to produce 0.75 watts per square feet. This is limited to the gross condition floor area of the 3 largest floors. There are some exceptions. However, if the exceptions apply, you still have to provide off-site renewable energy. So no matter what renewable energy is required, it's just a question of whether it's on-site or off-site. As I mentioned, it is 0.75 watts per square foot for on-site systems, and then there are a list of exceptions that will capture situations where on-site systems wouldn't produce very much power or wouldn't make financial sense. So there are some exceptions listed there. The simulated performance path, there has been a change here in the calculation to determine the percent of annual energy cost of the standard reference design. This equation now includes the energy efficiency requirements that would be required for the building type. So basically, the goal or the target of the simulated performance path now includes the energy efficiency credits that would be required if you were going through the prescriptive path. So basically, this is saying we've included the additional energy efficiency requirements within the performance path. So if you go performance, you don't have to worry about that. They are included within the calculations. All right, going to keep moving on here to the existing commercial sections. So, change of occupancy or use, as Ryan said, this is a somewhat big change that could catch a larger number of projects. Certain occupancies only need to comply with C503 rather than 505. Those are listed there at the top. Um, there is a 5,000 square foot threshold for this, so projects that are under 5,000 square feet won't fall under change of occupancy or use. But the main difference here is that the determination of whether a project needs to comply with the additional efficiency measures or not, or needs to comply with the full change of use requirements, is whether or not it triggers the energy use intensity mark here. Beforehand, the code was phrased something along the lines of if the energy use of the building increases or the energy intensity of the building increases, that was usually determined by an increase in electrical or gas service size or increase in HVAC equipment size. Now, there are actually tables, such as this one, that rank energy use intensity based on project occupancy classifications. So the sections are now written such that where a change of occupancy use results in the same or increased energy use intensity, then it must follow the full C505 requirements as if it were a new building. So basically, if you were moving from an A1 occupancy into a B occupancy, you would have to follow C505 and the full requirements as that is in the same energy intensity rank. So only if you move down would you avoid these requirements. Existing building additional efficiency measures. So for additions need to achieve 50% of the number of credits required for what the new building would be if it was new construction. So a real quick example here, if we've got a 3,400 square foot commercial office addition, that's Group B occupancy, climate zone 4A. This project needs to achieve 35 credits. If we just go to the table and look, it says 70 credits, but since this is an existing building addition, it's 50%, so 35 credits. Building additional efficiency measures for alterations. This is where the definition of substantial improvements comes in. If the project fits under the definition of substantial improvement, then it must earn the number of required credits that would be required for a new building under C406. So substantial improvement. We have that slide here. Substantial improvement is designed as any repair, reconstruction, rehabilitation, alteration, addition, or other improvement of a building or structure where the cost equals or is more than 50% of the market value of the structure before that project was started. So if you trigger this 50% of market value mark, then the code is going to basically treat that building as a newer building in terms of additional energy efficiency requirements. Okay. Whoops. Move too quick there. Another big item that is related to roof replacement projects is now that the 2024 code now requires anytime rooftop HVAC equipment is replaced, the equipment curbs need to be increased in height such that the next time a roof replacement or roof alteration project is done, that curb is no longer an obstacle to installing the full code compliant installation. So in climate zones 4 through 6, these curbs need to be 17 inches from the roof deck up. So again, this is just basically eliminating a potential barrier to installing full roof insulation, as this is often a fairly expensive thing to get a crane on site and lift this equipment. So we want to get to these curbs when we can, when the equipment and the crane are when the crane's already there and the equipment's already being messed with. Okay, so touching on roofing real quick. So a roof replacement is very clearly defined within the code as an alteration that includes the removal of all existing layers of the roof assembly materials down to the roof deck and the installation of replacement materials above the existing roof deck. In some discussions through the code development process, we've come to understand that there is another roof project type that is not specifically defined within the code, and that is just a roof alteration. Roof replacement is a specific type of roof alteration, but a general roof alteration is any altering of the roof system that may require peeling up an existing membrane, removing some insulation, but not all, installing new insulation, and then installing a new membrane down. So the key point here is basically that a lot of roof replacement projects out there are actually roof alteration projects. So make sure that if you're a contractor or you work with contractors who are doing roofing projects, that they're being specific about what project type their project is falling under. Is it actually a replacement of all materials all the way down to the deck, or is it just an alteration where may not include all of those materials down to the deck? Um, all right. At this point, I'm going to launch our next poll question here. All right. So our next poll questions are, how will the updated change of use provisions impact existing building projects? Your options are more projects will be qualified as a change of use. The entirety of the building will be required to be brought to code regardless of the area being changed. It will enable buildings to meet building performance standards or BPS. Second question, why does C50336 require raising roof curbs during equipment replacement? To add cost to projects, to make the equipment easier to access for maintenance and repair, to enable a future roof alteration project to install the required insulation.
And I see we've had a couple of questions come in. Yes, the PDF of these slides along with the recording of today's session will be made available on our website, as is our previous webinars. So if you do wish to go back and take a look and catch a recording from our previous webinars as well, that's available on our website. And another one I see, a UA, it's actually just a initialism for U factor area. So that's where they previously just called it UA, just for shorthand rather than trying to explain it. So that's why they've changed to thermal conductance, or TC, as that's much more descriptive than just U factor area.
I'm going to go ahead. It looks like everybody's stopped here, so I'm going to go ahead and end the poll and share these results. So it looks like the majority of everybody got the first answer right, that more projects will be qualified as a change of use. And then the vast majority of everybody really got that second question. The main reason we're raising roof curbs is to enable the future alteration of a roof to include more insulation. So good job there. With this, I'll pass it off to Ryan to take us through some residential updates.
All right. So I mentioned earlier about the update of the intent. This was also changed in the commercial provisions, but recognizing in the residential here, focusing on life cycle cost effective is the purpose of code improvements, recognizing that as technology changes and practices improve, what is life cycle cost effective, as well as energy prices change, will adjust as well over time. So as far as inspections, calling out that there's now, they broke out the air barrier from the insulation, as well as adding to the electrical rough-in inspection, with more and more controls being required. So inspections have grown in the residential provisions. So a few new definitions, common areas, demand responsive controls, grade plane, that's a new one for the residential, and on-demand pilot. We don't see, the code has not permitted continuous pilots for some time, especially for lighting fixtures. So adding on-demand pilot, solar ready zones, as we're now adding renewables, or at least provisioning for renewables into the future, space conditioning, as well as substantial improvement has been added for residential. So this is a note as far as when you look at the table. This table has been transposed, which is why the entire table is in blue, even though for our climate zones, it's only the vertical fenestration U factor that's been improved slightly. It's moved from 0.3 to 0.28, but the entire rest has been the same. So the table, they've just pivoted the rows and columns for that. So just being aware. But So some of these changes have not been nearly as dramatic as they show up in the text. So here again for component performance alternative using the TC rather than the older UA standard for that. Well, this table continues to be adjusted over time, R402511. This, you see here knee walls have now been added to this table. This is a really good table to key in on, as oftentimes most of the building science and building issues we encounter uh, go back to things that were missed from this table. As you notice, this is for air barrier and air sealing criteria, along with insulation installation criteria. So these are some very good things to key in on as far as designs and inspections. Mentioned about unit sampling, so recognizing you might have a commercial, a residential building. Apartment buildings can be rather large and still qualify as residential buildings, as they would be 3 stories or less in height. So sampling allows for sampling of 20% of units. So if you've got buildings with 8 or more, you got to test at least 7 or 20%, whichever is more. There's also a provision in here where in the event that a unit does not pass, additional testing is required for that. So again, this is similar to the commercial provisions. Air sealed electrical and communications boxes. So this is for boxes that actually penetrate the air control layer or where your air barrier. So this is one of the things to key in on is identifying where is that air barrier and is this box penetrating that. Part of this is also making sure that you install it in accordance with manufacturer's instructions, as oftentimes there is some additional sealing. It's not just the product, but it's a product with installation method to achieve that. So making sure we follow those manufacturers' directions. Duct leakage has now been added based on the number of ducted returns. So systems that have more returns often are able to provide better airflow at lower pressures. So in operation, that's where they're giving you some additional allowances for air leakage if you have more returns or more ducted returns specifically for that. So this table has grown. Previously, it was 3, 4, and 8. So you also see there's an additional row in here for space conditioning equipment. It's not installed, but the ductwork is located entirely in conditioned space. So previously in the 2021 version, it didn't specify whether the equipment was installed or not. So few changes for duct leakage. Pipe insulation, previously it said just an R3 for the pipe insulation. Now it calls for a 1-inch thickness of pipe insulation. They also do have a conductivity range there as well. So if you wish to use a different material of a different thickness and not just automatically go with the 1-inch, that was determined based on that conductivity, and there is a provision to allow you to use a different thickness if you use a different conductivity insulation for that. But this is going to be an increase in insulation, as you see in this range, moving from an R3, we're now moving up into almost an R4 or R5, depending on your temperature rating. So toilet exhaust. This is another notable change is it now requires either a time control, occupant sensor, humidity control, or contaminant control for that. So just your standard toggle on-off switch is no longer permitted for intermittent exhaust control for bathrooms. So you now have to have some form of automatic control so that we don't end up inadvertently leaving the exhaust fans running for hours on end accidentally. Electric resistance. So if you have detached 1- and 2-family dwellings and townhouses, if you do not use heat pumps, you are limited to no more than 2 kW of all electric space heating for a dwelling unit. So being aware of that. So you do need to uh, use a heat pump if you wish to have heating larger than 2 kW for a one, two family dwelling or townhouses. Mentioned bringing the outdoor heating provisions over from the commercial side, so now allows for heating outside. These do need to be radiant as well as controlled by an occupant sensing device or a timer switch, uh, such that we don't accidentally leave these on when no one is around presently. So, as well as some new controls for roof and gutter de-icing. So you'll notice here talks about moisture sensors, because obviously we don't have to de-ice if there is no moisture present. And then similarly, uh, daylight, so we're trying to minimize the operation of these. So get into uh, interior interior lighting controls, now adding lighting controls in most all spaces inside residential buildings, either for habitable spaces with manual dimmers or automatic shut off, automatic occupant sensor controls. Uh, Recognizing that bedrooms probably will go with manual dimmers, as installing occupant sensors in bedrooms is probably not a wise choice. But then for other spaces that are not habitable spaces, they do call out, such as garages, unfinished basements, laundry rooms, and utility rooms. We do have to have that occupant sensing controls for those spaces. Again, wanting to make sure that people don't leave lights on when they're not, for large homes. So if you're over 5,000 square foot per home or per dwelling unit, now you have some additional efficiency measures for this. Well, and similarly, simulated building performance requires an additional 5% improvement for these large homes. So here's just a brief example. So if you're doing a new residential building, you got to pick up 10 additional efficiency credits, and you have to do at least 2 different measures. Part of this is there are a handful of measures that you can get 10 credits. But this is encouraging designs to take a holistic perspective and make sure you're improving the whole building, or at least multiple systems, rather than just picking the one measure because, oh, that gets me my points, and so I'll just grab it without taking a look at the broader picture. So, and again, for dwelling units over 5,000 square feet, they have to have 15 total credits spread across at least 2 measures. So here's a look at what that table looks like for the additional efficiency measures. You notice here in climate zone 5, you know, if you get to a 30% reduction in your total thermal conductance, you can actually pick up 11 points. But saying, okay, we want to make sure that you don't grab all of your points just from this one reduction in TC. Now, to be fair, you're probably going to pick up something from another category while you're doing that as well. But we don't want you to be double dipping. So as Robert mentioned earlier about double dipping, uh, so if you say, okay, I'm putting in better windows, and so uh, I can't take both of those measures necessarily together automatically. You have to make sure that you have segregated your improvements between your 2 measures. For a simulated energy performance, so recognizing we've seen a lot more of this under the 2021, and probably we'll also see this under 2024. Again, picking up for dwellings larger than 5,000 square feet, picking up an additional 5% annual energy savings for that. So as far as looking at the performance envelope backstop, uh, it is now based on just 115% of the current code cycle. So rather than looking back to an older code version and saying your envelope, can't be worse than this. They just say your envelope can't be greater than 115% of what's allowed in the current one. So this applies for both simulated energy performance as well as the energy rating index path for that. So that way you only have to look up one code, and because you end up needing to calculate your prescriptive UA anyway, that you just multiply that by 115% to get what your backstop is. Air leakage previously under the performance path was limited to 5 air changes per hour. That has now been adjusted downward to 4 air changes per hour. However, we still call out here that projects are still evaluated based on their design. So this says, if the designer called for an envelope to be 2.5 ACH, that is what that building is to be evaluated against, not this 4 air changes per hour backstop. It just means that even under a simulated energy performance, if they went through and said, I'm going to model this based on a 6 air change per hour leaky envelope, the test would still have to meet 4 or less, because that backstop would then apply. So looking at the building performance, you see several things have been added for this. So those buildings using simulated energy performance have to go through and they have to meet all of these different requirements. So including things such as rooms containing fuel burning appliances, slab on grade floors, etc. So we still have to do air leakage testing for this. For existing buildings, so if you have substantial improvements, and again, this is very similar to the commercial substantial improvements where it's greater than 50% of uh, of your market value, that is definitely a substantial improvement. So if you do this, then you do have to pick up at least 3 credits here. So again, rather than a new construction where you got to pick up 10 credits, here under substantial improvement, just 3. Existing building duct testing. So if you are modifying or changing 25% or more of the registers, the total duct length, uh, then you need to do duct leakage testing in existing buildings. So 25%, that gives you a fair bit of flexibility for that before you do that. Again, part of this is just verifying that the system is reasonably intact. So with that, got one more poll here. Which of these is new for the 2024 IECC? Building electrification for residential buildings, increased wall insulation requirements, or additional requirements for dwellings larger than 5,000 square feet? Question number 2, which of these are Illinois amendments? Electric readiness for small equipment in commercial buildings, nominal increase in building efficiency for commercial buildings without heat pumps, or eliminating the trade-off permitting a worse performing envelope. Um, do see a couple other questions here. A good question here. Illinois, State of Illinois Electric Vehicle Charging Act. That is separate from the Illinois Energy Conservation Code, and there does not appear to be any. They are closely related, but they are different from each other. They are not being incorporated into the energy code per se, but the Illinois Energy Vehicle Charging Act still does apply for buildings and projects out there. All right, looks like most people have answered. Go ahead and end this poll. All right, looks like this one. All right, people picked up on this one much better. All right, so for the question one, which of these is new to the 2024? Most everyone picked up additional requirements for dwelling units larger than 5,000 square feet. Yes, that's the one. Which of these are Illinois amendments? It's actually all three of them. These are the three Illinois amendments for that. So with that, if any folks do have questions, feel free to reach out to us at our email address, energycode@illinois.edu. And on behalf of Robert Schlorf and myself, I'd like to thank all of you for attending and participating today, and have a wonderful rest of your afternoon.